today. So I bought an auger and basically bought the auger for my digger, and the end of the auger has broken. So this is what the end of the auger looks like now. As you can see, it's rather broken. Yeah, it's completely split apart, and this also bent. So the plan today is I'm going to use this bit of round stock here, and what we're going to do is we're going to CNC machine a couple of flats on this, so it's flat either side, but we're going to leave a bit of meat on. So it's going to be, this is 60 mil, it's going to be 50 mil with the flats. That's just so I can drill holes in it easy and put a bolt through. So first operation is going to be face this side, flip it around and use that as a reference point to face this side. Then we'll stand it up, and those flats give me something to hold in the vise. I'm going to go through, I'm going to bore a 30mm hole. So that 30mm round hole is going to be the diameter of the inside of this pipe. So I'm going to put a solid piece of round bar in that. I'm going to plug weld that in and weld round it. So that'll attach the round bar to this piece, and then that's going to go inside the actual auger itself. And then I'm going to plug weld up that, and hopefully that'll give it plenty more strength. And then once we've done that, we're going to flip it back over, grab on those flat spots again with the vise, and then we're going to machine the square into the top of this so that slides on, and then you'll be able to put a pin through, and then the auger should be nice and straight and work again. Yeah, this will be sort of the first time I've really done an actual project on the machine. The rest of it's just sort of been testing and playing around. So yeah, we will, I think I'll go through and we'll have a look at what the cam operations that I've got. So I'm using Fusion 360 to do the CAD and the cam to create the toolpaths for the machine. So we'll jump over to the computer and we will model up the part and then create the toolpaths, and then we'll jump back to the machine, back to here. And then we will, fingers crossed, have a go at machining the part. Might jump in and I'll show you the auger and everything that's broken, and maybe some bits and pieces about that too. But yeah, stick around for the machining. It should be quite interesting. Fingers crossed I don't crash the machine, but if I do, I've got a couple other end mills and things. Yeah, so let's crack into it.
All right, so anyone who's done a bit of machining will know that this is Fusion 360. So basically we've chosen a plane. We're now drawing a circle, and the circle is going to be the dimension of the slug of metal that we've got, which is 60mm. We're then going to extrude that out to 85mm, and that's the dimension of the actual part that we have in real life. So then we're going to draw another circle on that, and then this circle is going to be the size of the piece of round bar that we're going to put inside of it, and then inside of the auger itself. So we draw the circle, and then we extrude that circle back by 28mm. The reason I went 28mm is because that's the maximum cutting depth of the 12mm end mills that I have. So then we'll flip the part around, we're choosing the other side, and we're going to draw a center point square on that. That square is going to be 30mm by 30mm. So after we've drawn the square, we're just going to put some radiuses just on the outside. So basically, once I select all the corners, I change the radius value to 6mm, because 6mm is half of diameter, and the diameter of the cutter is 12mm. So if we put a 6mm radius, that means the 12mm cutter, when it goes into those edges, it's nice and easy for it, and it doesn't have to remove any more material than it would have to. So basically the radius of that is the radius of the cutter. So once we've got that, we go and extrude that again by 28mm. So once we've extruded that by the 28mm, that's the part that we've got. So that's basically the start of it. So then what we need to do is we need to put some flats on each side of it, and the flats are going to do a couple of things. They're going to allow me to basically drill a hole through it and put a pin through, and it's also going to make it easier for when it comes to the time when I actually sit it in the vise and grip it, because at this stage I don't have any V-blocks, so it'd be a bit hard to stand it up on its end to machine the square and the circle without having the flats there to push up against the vise. Now here I made the mistake where I put the dimensions in wrong. Yes, it moved it 50mm apart, but it didn't move both of the lines from the center apart. So the idea was draw a center line, and then basically make that a line that is, it's not a line for anything, it's just a line for measuring off of. So measure both sides of those. That made the diameter or the thickness of that part 50mm, and then went and drew a big circle, and then that allowed me to create those blue spots, which I can extrude back all the way through the part, and that creates the flats. So basically once that's done, that's pretty much the finished part. There's a couple more things that I had to do to it. So on the square side I need an 8mm hole, and that needs to be halfway between the 28mm depth of the cut and the end of the piece. So half 28, 14mm. But Fusion 360 is actually quite cool because you can, so you'll input the dimension of the hole, which was 8mm, and then, or 8.5mm, and then once you've got that dimension of the actual hole, you can use Fusion 360 to do the maths. So if you're not very good at maths, you can get your diameter of the hole, and you'll see here now I go click that, click the end, which actually I failed again on this one because I didn't have a center line or a line on the end of it. So I think I figure that one out in a second. As you can see, put a line in, change it into just a line that I can measure off of. That's not it's not for anything, it's just a measurement line. As you can see, I'm still clicking on the wrong spot because I'm not actually clicking on the line. I think I turn it around in a second and you'll be able to see the problem. So you can see there that there's still a circle there. So these are some of the weird features of Fusion 360, and I thought maybe I could turn the sketch off, but for some reason that sketch wouldn't turn off. So in the end, I turned it back around to that face, and then if you click above the actual part that you're looking at, click there and click there, you can actually set that dimension still off of that line, and you can see here I'm doing the math. So 28 divided by 2 gives you the 14, which gives you the dimension away, and then extrude that right the way through, which creates a through hole for the 8mm pin. That'll go through that whole entire block, through the auger, and that's basically what attaches the auger to the actual, or to this part to the actual auger piece itself. So then on the other end, once I'd done that, I drew another circle, not there. An idiot. Draw another circle, and this one I made 12 mil. I just made it 12 mil because I'll be able to fit a welding rod down inside that to be able to plug weld the inside of that part. Now I might even have a go at using the chamfer mill and set up another toolpath and use the chamfer mill to be able to set up a basically a weld V-bevel on the end of it, because I'm going to weld the end and then I'll plug weld these two holes as well, just to give it a bit of extra hold on that auger, because I really don't want to bend it or break it again, and this piece of metal is going to be sizably bigger than the other one. So yeah, extrude that hole all the way through, and then that there is basically your finished part. So once you got your finished part, then you can move over to the cam side of things. So here we are in the cam software. What I've done is I've basically set the machine up, chosen a tool, and then basically I've made that circle part into a square box to make it easier for actually milling the part. So as you can see here, the toolpath is cutting down the length of the part, but this is actually just taking it all in one big cut, really. So I ended up going into the settings of the actual toolpaths and dropping the passes down to 5 mil per pass, just to try and save the cutter a bit, because the spindle that I have doesn't really have enough power just to bore through straight up 10 mil of steel. So I ended up doing it in a few passes, just to save that cutter a wee bit. It all turned out reasonably well after I had done the toolpath. So there you can see that there's multiple passes that it actually does. So yeah, the multiple passes on the cuts actually made a huge difference, and it didn't sound like the machine was bogging down, because when I've done testing before with the machine and tried to do sort of a heavy, deeper cut, you can really hear that motor ramping down and just sort of not struggling, but it will bog down a little bit, and you can noticeably hear it. So yeah, just by taking lighter cuts, it does take a little bit longer, obviously, but for saving the life of the tool and not pushing that spindle too hard, the spindle itself could take it, but the motor and VFD won't. They just bog out. The VFD, a couple of times now, I've tried to push it through steel just manually by hand, and it's actually stopped, like completely stopped partway through the cut, and I ended up breaking a tool by doing that, because obviously the spindle stops spinning, but those servo motors, they've got so much power that they're able to basically continue moving while the spindle isn't moving, which is a bit of a pain. So yeah, once that's done, basically that's the first part's done, so I can move on to setting up the holes in the top there. Now you'll see I struggled a little bit with this, because this is sort of the first time that I've really delved into the cam side of things. I've done quite a bit of drawing stuff in cam, just by, for 3D printing and things like that, but the actual, in CAD, but in cam here, setting up on parts like this was a bit of a challenge, because there's no, having that round sort of was playing with my head a bit, but once I figured out that I could actually, on the stock box there, I could set Z, and I could set Z down it, and then I could set X along that straight cut face, and then have my origin point in that corner there, it made it not too bad to actually set up the cam for that. So basically I just did that for both sides, and yeah, had to watch a YouTube video on the best way to essentially make the cuts and clear out the holes. So yeah, you can see here, select X for that plane, and then I set Y to that for some reason. I played around with this for quite a while, and just to figure it out, because I'd rather play with it and figure it out than, have to continually watch YouTube videos on how to do things. I have the rough knowledge on how to get it set up, but it's better just to play with it, in my opinion, and then figure it out that way, because you sort of learn more in that respect. So you can see there yeah, I'm really having trouble there. So I finally figured out there, use the Z for the up and down face there, or for that line, and X on that line, and then basically flip the X around, and then that sets my origin point or my directions correctly to how I wanted to set it up in the actual the mill itself. And then when I set the box up, set it to that side, so that I know that once I go and probe that left hand side with my probe, that'll set up my x-axis, and then I probe that front flat, that'll set up my y-axis, and then I probe the Z on top, and then that sets up the Z height. And then my 12mm carbide end mill, that's basically got an offset off of my probe, and then the probe is set up 0 to the actual bed of the machine. So once the probe is set to 0, I can use the tool height offset tool setter that I have from CNC for PC, and then basically I can just bring the tool down and click the Z set button, and that will set an offset between the probe and between the tool itself. You can see here I was having a few problems, but in the end, go back into the edit, and I was able to figure out how to actually set up what I wanted to set up to be able to bore this hole out. Again, trial and error, more error than trial, but that's okay. You got to start somewhere. And yeah, for anyone sort of looking to get into this kind of stuff, this is the best way to do it. Just learn by doing. You can see I tried multiple different things, and a lot of them didn't work, but once I figured out what did work, I was able to actually generate a toolpath, which clearly here I still haven't generated the toolpath. So yeah, go back into it. So eventually I figured it out how to get the toolpath to work properly. So good thing to do once you've actually got a toolpath working is to simulate the toolpath. I found that by simulating the toolpath, I was able to make sure that I was definitely going to be cutting what I thought I was going to be cutting. As you can see there, I've got it cutting down about 5mm. I'd like to be able to figure out how to not have so much retract. I don't think it really needs to retract out of the part that much. My machine is pretty fast, so it is a quick retract, but it's kind of pointless if you ask me. I'm pretty sure there is a setting in there to be able to set it up so that it won't won't essentially retract all the way out of the part. It'll retract up a little bit and then start the cut again from the center of it. I'm sure there is a setting, but I'll just have to play around with that and figure that one out. So as you can see, the toolpath actually works. It's dropping down, it's going around, and it's cutting 5mm at a time. Comes back out, comes back in. So that's a toolpath that's going to work for that round hole. Right, so after generating the toolpath for that roughing cut, I went in and did basically a finishing pass. So again, dropping down the 5mm, and then just doing a single pass around just as a finishing pass. I left some stock to leave on the first roughing pass, so that I could come through with the finishing passes after that. So once that was done, I was pretty happy with all of that. And then after that, it was time to flip the part around and sort out the toolpaths for the square. So again, I had to set up all the origin point where I wanted to start from. I always go on the left hand corner. Reason for that, I watched a lot of Titans of CNC, and they generally set up their parts from that bottom left corner, and then everything works up and to the right of that. So again, you can see there I've got my X going to the right, I've got my Z facing up, and my Y going to the back of the part. Set the origin on that bottom right hand corner. So when I set it up, that would be, and it's actually incorrect on that CNC mill picture there, but when I have that set up, that means I can probe from that left hand side and from the back of the part, or the bit closest to me, and that's where my XY comes from, and then Z obviously is always on the top. So again, went in with an adaptive clearing, just to clear out majority of the stuff. Now, I actually made a mistake on this part here, as you'll see in the next part of the video. I really should have checked there's the mistake there. At the time, I wasn't really thinking about it. I thought, oh yeah, that looks good. But yeah, you will see why this was not good in a minute. So yeah, it's ramping down, and as you can see, that's all it's doing is ramping down, which is not really what I wanted to do, and that had some pretty expensive consequences. But again, you'll get to see that in the upcoming part of the video. So you can see there now it's trying to take a full depth cut into the side of the material. Yeah, thought it was a good idea, but not.
All right, well, welcome back to the machine. I guess first thing to do is home the machine so that the probe offset knows exactly where it is in space, and then we'll be able to start getting the piece of steel in the vise and start probing it in, getting it ready for machine operation 1. So I'm using Mark IV, so we'll just enable it, and we will reference all the axes back to home. Now the bit of wood that I've got that sitting on, it's a bit of technology there. Basically, I haven't built a counterweight for the back of it, and the head is too heavy So once the servo motors in the machine shuts down, everything turns off, the head just drops. So yeah, I have to go ahead and do that. Right, so we've got the button all set up for the automatic tool changing, which eventually will be a full automatic tool change. But for now, nice and simple, push it in, press the button, away it goes. So I guess first thing to do, we've referenced all the machine. We'll just roughly bring the machine over to where I want it. And may as well get this piece of metal into the machine. Right, so we'll just undo the vise. Make sure there's no chips or anything in the vise. Then I'm going to sit that in there. That's going to be, well, it doesn't really matter where it sits, because the first operation is going to be just machining the top off. I should have enough space between here and the top of the part where it's going to be machining for it not to not to mill any of my vise, but again, we're learning here, so we'll see what happens. Right, so that's nice and tight in there. So what I'm going to do now is I'm going to bring the machine down. Right, bring the machine down. Roughly find my center point, and then going to set up and do some probing. So it's going to be a bit of a tricky one, this, because I think what I'm going to have to do is I'm going to have to find the top and then drop down 30 mil from that 0 point, and then I can probe the x-axis in, and then I can probe the y-axis in the front. So I'm going to use the keyboard and get that as centered as I can. Slow that speed down a little bit. Yes, I know there's probably a better way to do this, but again, rookie machinist, not 100% sure how I should be doing this, so we're going to go with this method. So we'll probe Z. So that's Z probed. So that puts me 20 mil above. So if I move that over and then I go down, if I go down to negative 50, yeah, negative 50 because I'm at 20, go down to negative 50. Okay, I'm just going to bring it down by hand. It actually really doesn't matter because realistically I'm taking more of a cut than what I need to, so right, we'll call that there. Alright, so that's got that. So that's X aligned. Oh no, I've faced off both of these ends in the lathe before I actually put it in there after I cut it on the bandsaw. And then we'll get Z, Y set. So Y is all probed in. Right, so that's all my heights done. I already have my tool offset table set up with the tool. So we should just be able to flick the tool over, put the 12mm end mill in, and now we should be ready to start the first operation. So everything there's set. So what we'll do now is we'll bring the first lot of G-code in. Okay. Right, I have to go back to the computer and re-post process. Right, I made a bit of a muck up with my post processing, so I've got that sorted now. So I've loaded the post processor in, all the stuff zeroed off. So we'll hit cycle start. Not sure what it's doing there. It should have gone should move a lot faster than that. There we go. Manual tool change, tool 2. And we'll hit cycle start and hopefully the machine doesn't crash. Right, well that worked. So I guess I'll flip it over and probe it in again. Flip it over, probe it in again, and then we'll do the next flat on that. That feels quite nice. I'll flip it over, do the next flat, and then we can stand it up and do the next lot of G-code. And I have to put something under that. So that looks not too bad. Feels pretty smooth, pretty flat. There's a tiny bit of you can't really feel it though. Yeah, pretty good. Right, I'm going to have to put something under that. So I'll sit this block in there, and that'll push that up off of there so that I don't crash the machine into my vise, because that would suck. Right, change back to tool 1, probe, and then always seems to do this. Has anyone got any ideas on why it might do that? It seems to get stuck in there for some reason after I've done machining. I'm wondering if the piston doesn't come down far enough. The ram's not pushing down far enough, maybe. And yeah, but it only seems to be after I've cut. Every other time that I do anything else, it seems to be fine. Yeah, unsure why. Right, so tool 1's back in. Bring that back down. Find my X, Y, and Z again. Again, doesn't really matter where because we're only facing the top off. So it's not really too much of a concern to me. That's very close. Y done, and then now, of course, when I start machining more technical parts that need to be a bit more accurate, I will most definitely be doing better setups than this. But for now, what we're doing here, it's not really too much of a biggie. Like I say, this is literally just for a digger. Right, tools in, change back to tool 2, cycle start. Rightio, well that's those cuts done. So they were 5mm depths of cut. 5mm depths of cut. Yeah, that seemed to go pretty damn well if you ask me. So that's the two sides now machined, just like the picture. I should probably learn how to use the chamfer mill too. So I have one of those. Again, the surfaces are pretty reasonably smooth. I think the tram on my head may need looking at eventually, but it's okay for now. Right, so that's that operation done. So the next operation is going to be the bore on the top. So that'll be the hole. So get that in there. Now, if there are any actual real machinists out there that want to chime in and give me some advice, tell me what I'm doing wrong, that'd be great. Or if there's anything you maybe think that I could improve on. Yeah, see, it did it again. I keep having to shove something like that in there. Which I shouldn't have to do. Ow! Oh, look at that. Broke the end mill. How good. I really got to figure that out because that's $20 end mill down the toilet. Arrgh. Oh, good. Bleeding. How good. Right, I've changed that end mill over, so now I'm going to have to retouch my tool off, retouch this tool off, and then, yeah. Luckily, I have a touch probe that I can just bring that tool down onto and reset for tool 2. Tool 2, and then now it's advisable to put your probe or your touch plate in basically the same spot every time and do your touch offs from there. So this is tool 2. And then material top, tool length offset, like that, just to make sure. Yeah, so on the computer here, you see down there, that number, that 43, that was the old tool height. So what I'm going to do now is I'm going to bring this tool down onto that touch plate, and that number should change because tool 1 is 0, which is my probe, and then I've got on here 52 mil, that's the height of my touch plate, and then that number there should change to give me my new offset for the new tool. Negative 119. Don't think that's right. That's better. .64. That should be right. Right, okay. I don't know why it came up with 119. Right, so that's that set. I know why. I need to reference everything back to home because I reset the tool Z for that last operation. So I'll just reference everything back to home, make sure that I am home, or Z0 for everything. And once everything's zeroed back to definite 0,
So it was about at this point that I realised, or didn't realise, that my microphone had gone dead. So there was a lot of talking about something here, but I can't remember what it was. So yeah, I'll fast forward through to the more interesting bits. So the audio was still missing on this part, but I think what I was talking about is the fact that there's my tool height offset setter. So basically probe the bed, and then when I go and probe the tool setter there, or not probe the tool setter, but drop a tool down onto that tool setter, I just set an offset of 52.568 millimeters, because I think it's a imperial measurement, so it's a funny measurement in millimeters. But yeah, once I've done that, move the spindle above the part, and then brought it down to probe the X, Y, and the Z heights. So here I'm probing the Y axis. So basically bring it down, and then I use the probing inside Mark IV, which is quite good. You can see the light went off there and it moves back 20 mil. And then I move it over to probe X, and I pretty much just winged it where the end of it was, because it didn't really matter. It's not a critical part. There is a way to basically set the dead center of it, but I wasn't too concerned about it this time, so I pretty much just lined up the probe, the center of the probe with the center of the part, where I could see the little end piece where I'd finished machining it on the lathe. So that should have been rough enough dead center for this job. So yeah, lined it up with that, and then moved it over and dropped it down. And then you'll see the little green light go off again when I press the button, and you see the table moving. The green light there, so that's set X0 and Y0, and then I just bring it across and drop it down onto Z. Once the Z height's set, that's basically it for setting up the part. The probe makes it so much easier to do. Before I had the probe, when I was setting things up, I had a feeler gauge, and then you'd have to put the feeler gauges offset into Mark IV to tell it where it was, and yeah, it was just a pain in the ass. So having this probe from CNC for PC has sort of been quite a game changer for how it's done. Here I would have been saying about how I hadn't changed it from tool 2 when I was doing the tool offset back to tool 1, which is my probe. So the offsets would have been all incorrect, because obviously the head would have thought that it's 52 mil lower than or higher than it actually is. So yeah, had to change it back to tool 1 and then probe the X, Y, and Z again. And yeah, once that's all probed, I swapped the tool out, chucked in that 12mm end mill, and then it's time to load the G code for what you would have seen me do in cam. So that's to do that first hole. So it was at this point that I freaked out, thought it was going to run into the part, and I pressed the emergency stop. Obviously, yeah, still hadn't figured out that my microphone wasn't working. But yeah, reset the tool or reset the G code, and machine went back up to the top. Went through all the same processes again, and then yeah, the machine started this time, and this time I just let it go. So as you can see there, I turned the rapid feed rate down a lot so that it didn't just plunge into the part. But it actually took a little while for it to start cutting. But as you can see there, it seems to be cutting quite nicely. Chips are flying off. This is real-time speed. I haven't slowed down or sped up any of the footage in this video. So all the cutting and machining that you're seeing is in real time. Yeah, I think coming up in the next videos I'd figured out that my microphone wasn't working, so you actually get to hear the machine cutting, because you hear the cutting loads on the machine, and the spindle's not too bad, but like I've said previously, it does bog down a little bit, which is a little bit disappointing. But I mean, you can't really expect too much from a 2.2 kilowatt three-phase motor. So future plans, I would really like to get probably like a 5 to 10 kilowatt spindle motor, proper servo spindle motor, and then that'll take
I think I just realised that my microphone is off and dead. So yeah, I will have inserted a voiceover for the rest of this, obviously. That really sucks. Yeah, this is seems to be going pretty well. So you see what happens when it gets deeper down into the hole. I think the diameter on that is 28 mil, and the length of the flutes on that is 28 mil, and the depth of the hole is 28 mil. So it's going to be right on sort of the brink. Could be a disaster. At this stage, it all looks pretty damn good. Pretty happy. Just disconnected the ear to the thing, so give us a little bit of chip clearance. And hopefully that'll stop any super bad stuff happening inside that door. Like I say, this is the first time I've actually...
I think here I'd turn the microphone back on, thinking that I must not have turned it on in the first place. But yeah, it had actually gone dead again. So most of the audio after this point is all just off of my phone, which is what I film on.
So guys, the microphone's gone dead. Turn the microphone from now turn the records up, so it should go up and down a bit. This is the finishing passes. Wow, that seemed to have went pretty well. Yeah, we'll get that out of there and we'll see what it looks like. I didn't realise that it would do the finishing passes all in the one hit for me. Yeah, but I suppose because I paid for I paid for a full license of Fusion 360, so that must be part of the license thing. Is that because I've paid for it, I get the all of the things in one hit. Okay, seems not too bad. We've got a bore there. I'll grab the calipers and I'll see how deep it actually is. So I think we were aiming for 28 millimeters. Oh, I don't know if you can see that. I think my Z offset's a bit wrong. That looks closer to 29 to me. But for what I'm doing here, probably close enough. And then the diameter should be, I believe I did 30.5. So it's probably not quite 30.5. Oh, maybe it is. Yeah, it's pretty close. Happy enough with that. Not bad for a first test. I'll go and grab the bit that's supposed to go inside it and we'll see if it fits. So this is the rusty 30mm bit of round bar. Oh, look at that, perfect. It's a little bit loose, but that's all right. I'm welding it anyway. So that's something to note that although this is 30 and this is 30.5, so I've actually got 0.5mm of play in there. So that's probably not too bad, really. Yeah, dimensionally. If I had to close that up to a bit less than that, maybe like if I had gone 30.25 or something, it would have been a bit tighter. But yeah, that's something to look at later on. Sorry about the audio quality, the microphone's gone dead. But yes, the bore seems to be pretty good. The finishes there are pretty good. So what I'll do now is I'll go and set this side up, and we'll cut the sort of the square into it. We'll see how that goes. That should be interesting. See if I can get that end mill out without breaking a flute off again. Would be nice, because that's my last 12mm. Might have figured it out actually. That might be because I had a funny feeling that the air compressor won't be at full tank capacity, so therefore that won't be pushing as hard and won't be pushing it as far down. But then again, that still doesn't really explain why it does it. You see that move? So it's not pushing down enough. Yeah. Does anybody know how to adjust that? If you do, down in the comments, because that'd be nice to know. Right. Change back to tool 1 this time. Hey, we're learning, guys. Change back to tool 1. Put that probe in. Turn that around so you can see it. Right, and close that G-code. We'll bring up our probing again. Oops. Bring up our probing again, and we'll probe this in, and yeah. Then we'll do the part that I've been dreading the most, and that's the cutting the squares. Y. And touch Z. Rightio, that's all the coordinates set up, so take the probe out and switch over to my other tool. Right, I'll load up the new G code, and so this one's going to cut the square and then it'll do like a finishing pass around it, so we'll see how that goes. Told you I'd fail. Oh good, and now I've broken that end mill as well. I really don't know what happened there. Yeah, don't know what to tell you, but that's that sort of screwed until I can get some more end mills, because that's broken the end off of that one. Wonder if that, yeah, must have just been too aggressive. So that's a bugger. Oh, need to plug the air back in here. Yeah.
So it's broken the tooth off of that one too. That really sucks. Yeah, I'm gonna I'm gonna have to look at yeah, so I guess I'm gonna have to look at how I set up my toolpaths and things, because I can't really afford to be breaking end mills like that all the time. Yeah, that was a big failure. Well, I mean, most of it went alright, but yeah, that last bit, breaking that's a bit of a pain, but oh well, it is what it is. So anyway, yeah, I guess thanks for sticking around, and I'll be back with videos on the probe and all of that kind of stuff and how I set it up later date, but thanks for watching.
Ah, tricked you. I'm going to give this another go. Essentially, this is now a 3-flute end mill. I figured out what I did wrong. I went and had a look back at the G code, and basically what I'd done is I'd run a spiral all the way down, and then I started taking full depth cuts with the end mill instead of spiraling down 5 mil and then making the square another 5 mil, make the square another 5 mil, and then step down on my finish passes. So I'm hoping with less of a pressure on the tool, I should be able to get the job done with the 3-flute. So yeah, fingers crossed. We'll see what happens. Make sure that vise is done up extra tight this time. So I'll chuck the probe in, and then we'll go through, we'll probe the side again, probe the front again, probe the top again, and then use our 3-flute end mill, hopefully to cut the part. Then I can actually get this project finished today, instead of having to wait for a month until more parts come from China. Right. I don't have that nice center mark this time, so we're just going to wing it and do it by eye. It looks close enough for X. It's good for Y. And that'll do our Z. Cool. Rightio. Chuck our 3-flute end mill back in there, and I'll load up the new program with the new parameters, and yeah, we should be good this time. Right. So there'll be a bit of ear cutting at first because obviously we've already got a hole in it. Ooh. Let's turn that rapid speed down. Stop. Why did the spindle not turn on? Ah, alarm. The alarm was still saved from last time, so we should be good now. Well, it still seems to cut as a 3-flute end mill, so that's a bonus. See whether it finishes the whole lot. Yeah, like I said, there'll be a lot of ear cutting on this one because it cut the middle out before it threw the thing out the vise last time, so it's only really going to be cutting the corners of the hole this time. I think that motor might need replacing, the spindle motor, something a bit more powerful. Maybe I need to look for something like a 5.5 kilowatt one instead of just a 2.25 kilowatt. The VFD that I had can run a 5.5 kilowatt, so yeah, might be a good upgrade for it. So this is the finishing pass. All right, sweet. Well, that looks like that finished. So I'll grab that part out and we'll take a look at it. Pretty stoked about that. Looks like using a 3-flute end mill worked just as good as the 4-flute one. Oh, the bottom's a bit ugly because obviously it got chewed up, but other than that, it's not bad. You can see in the corners, you could hear that sound where it sort of sounded like it was chattering a bit. It looks a bit liney, but it's actually pretty smooth. But you can see down the bottom, I can get the light. Yeah. See down in the bottom there, it's a bit crappy. Hang on. Yeah. See the bottom where it all got chewed up by that that end mill when it decided to explode on me. But yeah, other than that, I'm pretty damn happy with that. So that's the round side done, square side done, and the 2 faces. So that should be my part now. Yeah, that's awesome. I'm glad it worked.